questions 11 through 20 on the 2012 Grade 12 AMC 12A. Alex, Mel, and Chelsea play a game that has 6 rounds. In each round, there is a single winner, and the outcomes of the rounds are independent. For each round, the probability that Alex wins is a half, and Mel is twice as likely to win as Chelsea. What is the probability that Alex wins 3 rounds, Mel wins 2 rounds, and Chelsea wins 1 round? Well, first let's figure out their probabilities. Mel's probability of winning is given as a half. Alex is a half. And then Mel is twice as likely than Chelsea. So if this is 2x, this is x. But we know that 2x plus x has to equal half, right? Alex already covers half of the probability. So these two must have the other half. So 2x plus x is a half. That means 3x is a half. And therefore x is 1 over 6. So this is 1 over 6. And 2x is 2 over 6, which is 1 over 3. So those are the probabilities. A half, a third, and a sixth for each of them to win. Now we have to keep in mind that they want Alex to win 3 times. So we got to multiply that by 3. Then Mel has to win twice. So multiply that twice. And then Chelsea wins once, so just 1 over 6. So this is 1 over 8 times 1 over 9 times 1 over 6. And that is what? 8 times 9, 72. 72 times 6, 432. 1 over 432. But 1 over 432 is not one of the answer choices. You say, well, why not? Makes perfect sense, I hope. Well, that's because this doesn't take into consideration all the different possible combinations. It only takes into consideration one combination. There's many, and let me explain. You have Alex, Mel, and Chelsea, right? Alex wins 3 times, Mel wins twice, and Chelsea wins once, right? So what we calculated is one such combination. But there's others, right? For example, the order could be different. It could be Chelsea wins the first round, and then Alex wins the next 3, and then Mel wins the last 2, and so on, right? There's a lot of these combinations. So what we have to do is figure out how many of those combinations are there. So that shouldn't be too problematic. We have basically 6 different rounds. In the first round, we've got 6 possible choices, either A, M, or C. The next round, we only have 5 choices left, right? Because one's already been taken. And the next round, 4 choices left, 3, and then 2, and then 1. So that's the total number of combinations. But here's the thing. There's 3 A's. So you're going to have a lot of that are similar. So therefore, you have to divide this whole thing by 3 factorial. And then similarly, you have 2 M's. So then you have to divide by 2 factorial. That's how you get unique combinations. Otherwise, you're going to have a lot of overcounting. So if you do this math, the 3 factorials cancel. So all you're left with is just, because this is 3 factorial and so is this, so that's what I mean by cancel. You're just left with 6 times 5 times 4 over 2, and that is 3 times 5 times 4, which is just 60. So you have to now take this and multiply it by 60. And if you do, you get 60 over 432, and that's the correct answer. Now, of course, we have to lower this to reduce this to lowest terms, and I believe you do that by dividing top and bottom by 12. So 60 divided by 12 is 5, and then 432 divided by 12 is 36. So 5 over 36 is the answer, and therefore number 11, the answer is B. A square region ABCD is externally tangent to the circle with the equation x squared plus y squared equals 1 at the point 1, 0, 1 on the side CD. Vertices A and B are on the circle with the equation x squared plus y squared is equal to 4. What is the side length of the square? Let's draw our diagram here. So we've got a xy plane first of all, and then you've got two circles, and the first one, the first circle, has a radius of 1. So we'll just draw a circle like that. And then the next one, this one, has a radius not of 4 but of 2, because remember the circles have the equation x minus h squared plus y minus k squared is equal to r squared, where hk is the center and r is the radius. But in our question, hk obviously is 0, 0. The center of these circles is 0, 0. That's why there's no hk. And r squared is 4, so that means r is 2. So the second circle, just draw it. Doesn't have to be a work of art. Something like this. Now let's draw in our square. Our square is going to fit like this. Something like that, right? Where it's tangent right here. That point it touches. And let's label this. So we've got A and B are on the circle with the equation x squared plus y squared equals 4. So A and B are here. And CD is this guy right here. This is C, D, and D. And they want you to find the length of the square. Okay, so the length of the square, I'll just call it x. All right, so we have to fiddle with this now. Let's draw some helpful lines. Hopefully those lines can help us in this equation. So the first one I'm going to draw is from the origin to B. So from here to there, that one. And the next one I'm going to draw from B all the way down to this x-axis. And let's see here. Now this will be very helpful, yes, because the distance from the origin to B is the radius of the large circle. So OB is 2. And then the distance from here to here we have labeled as x, BC, it's the side of the square. But the distance from C down to the x-axis is just 1, because that's the radius. It's the same as this, right? It's just translated a little bit to the side. And then now this distance, that distance is just half of the square side, so it's x over 2. And that's it. And this is, of course, a right angle. So we've got a Pythagorean relationship. We've got x over 2 squared plus 1 plus x squared is equal to OB squared, which is 2 squared, which is 4. So that's the equation, and this question just boils down to getting a quadratic and fiddling around with the quadratic equation. So that's x squared over 4, and we can multiply through later. So we got x squared over 4 plus 1 plus 2x plus x squared is equal to 4. Multiply through by 4 and you get x squared plus 4 plus 8x plus 4x squared is equal to 16. Put everything on one side and you get 5x squared plus 8x minus 12. Right, so as I said before, we got to now fiddle around with the quadratic equation here. All right, not a problem. So x is going to be equal to minus b plus or minus the square root of b squared minus 4 times ac, all over 2 times 5. So it's minus 8 plus or minus 64. 4 times 5 times 12, so that is equal to 240, all over 10. So that's minus 8 plus or minus the square root of 304, but 304 I'll break it up into a mixed radical 4 root 19, all over 10. And obviously we want the positive one, because if we use the negative one, it's going to give me a negative value perhaps, and that's not going to work, right? Because you need a side that's positive, obviously. So this is going to be divide top and bottom by 2, so it's going to be 2 root 19 plus 4 over 5. 2 root 19, minus 4. Yeah, because it's minus 8, so it's minus 4. Yeah. So, of the answer choices, that is D. Paula the painter and her 2 helpers each paint at a constant but different rates. They always start at 8 a.m. and all 3 always take the same amount of time to eat lunch. On Monday, the 3 of them painted 50% of a house, quitting at 4 p.m. On Tuesday, when Paula wasn't there, the 2 helpers painted only 24% of the house and quit at 2:12. On Wednesday, Paula worked by herself and finished the house by working until 7:12 p.m. How long in minutes was each day's lunch break? So it doesn't really matter. We can just let the house be 100 square meters. The house size doesn't matter. You can use X, but then it'll just cancel out everywhere. So in the first scenario, it's P, Paula plus the first helper plus the second helper, them working together. And they are working from 8 to 4, so it's 8 hours. But then we have to subtract that lunch break, and I'll just call it T for time. And we don't know. That T is what we're trying to figure out in this question. And that first day, they paint half the house, so 50. The second day, it's just the 2 helpers, so it's H1 plus H2. And they are now working until 2:12, so that's 6.2 hours. And then again, you have to subtract that lunch break, and that is equal to 24. And then the third day, it's just Paula by herself, and she's working all the way till 7:12, which is 11.2 hours. But of course, we have to subtract that T from her, and that equals 26. Because it's the remainder of a house, and there's 26 left. So these are those equations. So if you put them all into one equation, this P is basically 26 over 11.2 minus T, this P right here. And then you add this H1 plus H2, but you can get that from here. That's going to be 24 over 6.2 minus T. And then this is all going to be multiplied by 8 minus T, and that's going to equal 50. So this is the equation we have to solve. It's a messy one. It involves quadratics and all that. So what I did, I just looked at the answer choices. And I said, well, first and foremost, let's convert these to hours. So this will be 0.5. This will be 0.6. This is going to be 0.7. This is 0.8. And this is just 1. And very quickly, I plugged them in. And the one that works, meaning makes this side equal to 50, is 0.8. Which is what T needs to equal for that to equal 50 to balance the equation. And therefore, number 13, the answer is D. The closed curve in the figure is made up of 9 congruent circular arcs of length 2 pi over 3, where each of the centers of the corresponding circles is among the vertices of a regular hexagon of side length 2. What is the area enclosed by the curve? Well, first let's connect the dots to make that hexagon like this. And when you connect the dots like that, you will see that this is a little bit more helpful. First thing I'm going to do is calculate the area of these segments right there, these blue segments. And each of them has obviously a section of a circle. Now, how much though? Well, the internal angles of a hexagon are 120 degrees. So that means the other side is 240. So each of those is 240 over 360 degrees times pi r squared. And there's 3 of them, so we have to multiply by 3. So this is 3 times 2 over 3 times pi r squared. Now what's r in this case? What's the radius of that circle? Well, they tell you there's a few ways you can figure that out. You can use that arc length, but I think a quicker way is just to understand this point that the hexagon has a side length of 2. So from here to here is 2. And because of the symmetry of this diagram, that means this is half of that. So the radius is just 1. So there's 1 squared. So this becomes just 2 pi. So that takes care of the blue guys. Now I've got to figure out the area of this part of that figure, right? This part right here. How do I do that? Well, that orange part, I'll just write here. Orange, I guess. Orange part is equal to the area of the hexagon, subtracting from it these guys. If you subtract these pi pieces, you will get the orange area. So it's 3 times those red areas, and those red areas, each of them is a segment of a circle. And remember, these internal angles are 120. So each of those is going to be 120 times 360 times, of course, the area of the circle, which is pi times 1 squared. So this basically becomes the hexagon times 3 times 1 over 3, which is just 1, and then times pi times 1 squared. So this just becomes minus pi. And that's it. So all we have to do now is find the area of the hexagon. Therefore, we can calculate the orange part, and then we can add it to 2 pi. So I'll draw the hexagon a little bit over here, just to avoid making that diagram too messy. And here we go. So now we have to figure out the area of this hexagon, and I'll cut it up into different pieces like that. And when you do, you can figure this out pretty quickly. This is, of course, 2. All the sides are equal to 2. Now this is a right angle, and this whole angle was 120. So that means this is 30. And this is a right angle, so that means this is 90. Or sorry, 60. 60, not 90. So it's a 30, 60, 90 triangle, and the ratio of the sides are 1, root 3, and 2. But those in this case are also the length of the sides, not just the ratio of the sides. So we can figure out the area of the hexagon pretty quickly now. The first segment is, of course, just that rectangle. So that's 2 times 2 root 3, right? Because this is root 3, but we want the whole length. And then we have to add those 2 triangles, this one and the other one. So there's 2 identical triangles. So 2 times 1/2 base times height. The base is 2 root 3, and the height is just 1. So this becomes 4 root 3 plus 2 root 3, and that's 6 root 3. So this hexagon is 6 root 3, and then minus pi. Now we have to add this guy with this guy to get up the total area. So that's 6 root 3 minus pi plus 2 pi, and that is 6 root 3 plus pi. 6 root 3 plus pi, which is choice E for number 14. A 3 by 3 square is partitioned into 9 unit squares. Each unit square is painted either white or black, with each color being equally likely, chosen independently and at random. The square is then rotated 90 degrees clockwise about its center, and every white square in a position formerly occupied by a black square is painted black. The colors of all other squares are left unchanged. What is the probability that the grid is now entirely black? So let's draw 2 squares, and let's talk about this. And here we go. So the first one, I'll label the vertices A, B, C, D. And when you rotate it 90 degrees, the vertices just rotate. So this becomes A, this becomes B, this becomes C, and this is D. And I'll also label them the individual boxes 1 to 9 to kind of illustrate what happens with those. When you rotate those, it becomes 1, 2, 3 here, 4, 5, 6 here, and 7, 8, 9 here. So a lot of these, will become something else. So for example, if you were to look at just the original box, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then draw arrows, I will label now what each of these boxes becomes. So for example, on the original square, the 1 is there, right? But then when you rotate it, it actually took 7 takes its place. And in a very similar way, 2 is the number for the square on the original shape, original position, but when you rotate it, 4 takes its place. So I put the 4 there. And similarly, I just fill all these out. 1, 8, 5, 2, 9, 6, 3, right? So interestingly, the 5 is the only one that actually doesn't change. So we want the end result to all be black. We want everything to be colored black. Well, the only way to get the 5 black after the rotation is to have it black before the rotation. Okay? So the black for 5 is pretty straightforward. And the probability of that is 1/2. So that's the easiest one to explain. But now we have to explain all the other ones, and it's a challenging question, so I'll try my best. The first one, of course, is understanding that we have to group these. So let's just look at the corners, 1, 3, 7, 9. We're only going to look at the corners first. Now, the corners 1, 3, 7, 9 have different possibilities, right? Each of them in the original position can have either a white or a black. There's only 2 possible colors. So for each of these, you have 2 possible colors for each. So to figure out the total number of combinations, you just multiply them all. So 2 times 2 times 2 times 2 is 16. 16 different combinations for those corners. And those combinations, you can pretty quickly make a list. It's not really that complicated. It's as follows. You can have either all black for 1, 3, 7, and 9. Or you can have other combinations, like you can have 3 black and 1 white. Or you can have 2 black and 2 white, like this, BW, BW. Or you can have WB and WB. Now what's interesting about these ones is that after rotation, they end up all black. And I encourage you to see why. I'm not going to go through every single one, but I'll just go through a couple. So the first one's pretty straightforward, right? They're all black in the beginning. Obviously, after rotation, they're going to stay black. So that one doesn't really need to be explained. But what about the next one? We'll write it here. This one's black, BBBW, right? So BBBW. Okay. When you rotate it, the B comes here. Then we have B here. And then the 9 goes here. It becomes B. And the W is here. So now let's talk about this. The question states that whenever you have a white that was previously black, you color it black. This is white, but it was previously black, so you color it black. And that's why BBBW, this one right here, becomes BBBBB, or whatever, right? So, like I said, I'm not going to go through every single one, but these 7, all, when rotated and you follow the rules of the question, turn into all black. But there's more, right? These are not the only combinations. You have 16. I only labeled 1, 2, 3, 4, 7. And the reason I did that is because these are the only 7 of the 16 that become all black. All the other ones don't. I'll just list those. And these are the other So 1, 2, 3, 4, 5, 6, 7, 8, 9. And those ones, when you rotate them, you don't get all black. So of the 16, only 7 of the 16 result in all being black when you rotate and follow the rules. So we figured it out for the corners, 7 over 16. We figured it out for the 5 is 1 over half. And for the other guys, the 2, 4, 6, 8, the good news is that it's the exact same story as what we did right here. Exact same. And I encourage you to do that. I'll let you do it since it's exactly the same. I don't have to repeat myself. So the total probability will be this 1/2 times this 7 over 16 and times another 7 over 16 for the 2, 4, 6, 8 story. And that's going to be 49 over 256 times 2 is 512. 49 over 512 is the probability. Number 20, therefore, is A. Circle C1 has its center O lying on circle C2. The two circles meet at X and Y. Point Z in the exterior of C1 lies on C2, and XZ is 13, OZ is 11, and YZ is 7. What is the radius of circle 1? Let's draw this diagram, see what we get. So here's our first circle, and we'll make our second circle so that it has O on it. So first let's label O. This is O, which is the center of the first circle, C1. And this circle here is C2. And then the two circles meet at X and Y, so this is X over here, and this is point Y. And then somewhere there's a Z that is on circle 2. So let's just say this is Z here. And they're saying now they've got lines that they're drawing. XZ, therefore this line, and OZ, and finally YZ. And they have given us lengths of 13, 11, and 7. So they want you to find the radius of C1. Okay, radius of C1 would obviously be from O to X or from O to Y. And we can just label that R for radius. Okay, so how do we approach this question? Well, there's one very important fact right off the bat. First of all, there's several approaches to this question, but there's one that I like, and that is understanding that this angle is the same as that angle. So if this is theta, this is also theta. That angle, what is that, YZO, is the same as angle XZO. Now you say, well, why is that? What is the reason you know those two angles are the same? And it's because they are formed by subtending arcs of the same length of C2. So, for example, just look at C2, this bigger circle. Look at, now from here to here is R, right? So that means this arc, O to X, the arc, is going to be the same length as that arc, O to Y, because from O to Y, that length of that line is R. So those arcs are going to be the same. And then what you've done is you've taken those 2 points, O and X, and subtended them to create this angle. And then you've taken 2 more points that subtend from an equal length arc to make that angle. And that's why those two angles are the same. So I personally believe that's the heart of the question, but depends on your approach. So now what you can do is you can use the law of cosines. The law of cosines first on this triangle, and then of course on the other triangle, and then off you go. So in the first triangle, you will get r squared is equal to 11 squared plus 13 squared is minus 2 times 11 times 13 cos theta. And on the second one, you get r squared is equal to 11 squared plus 7 squared minus 2 times 11 times 7 cos theta. So this will give you, for the first one, you can isolate for cos theta. And if you do, you'll get cos theta is going to be equal to, let's see here, multiplying this all out, it will be 290 minus r squared over 2 times 11 times 13. And then in the second one, the same way, if you isolate for cos theta, put everything on one side and that kind of thing, you will get 170 minus r squared over 2 times 7 times 11. And now we just equate them. We equate those two together. So that means 290 minus r squared over 2 times 11 times 13 is the same as 170 minus r squared over 2 times 7 times 11. So let's see here, the 2's cancel, the 11's cancel, so I can just multiply, cross multiply by the remaining denominators. So this becomes 7 times 290 minus 7r squared, and this is 13 times 170 minus 13r squared. Put all the r squares on one side, you get 6r squared, and then those numbers on one side, you get 13 times 270 minus 7 times 290. And this is equal to 2210 minus 2030. And we can divide through by 6 to get r squared. And therefore r squared will be 180 divided by 6. And therefore r squared is 30. That means r is root 30. So root 30 is the answer for the radius, and therefore that would be E for number 16. Let S be a subset of 1, 2, 3 up till 30 with the property that no pair of distinct elements in S has a sum divisible by 5. What is the largest possible size of S? Well, first let's write them all out. Now, in this question, we're going to use mod. And if you're not familiar with it, I'll give you a very quick crash course. For example, 1 mod 5 is the same as 6 mod 5. So what does this mean? Well, it basically means remainders. So if I take 1 and divide by 5, what is the remainder? Well, it's a 1. Remainder is 1. If I take 6 and divide by 5, what is the remainder? The remainder is 1. So that's why those are equal. So every number in here can be written as either 0, 1, 2, 3, or 4 mod 5. Any one of these numbers can be written like that. So for example, we can write 8 mod 5, and that's equivalent to, you take a moment and figure it out, 3 mod 5, right? Because if you take 3 and divide by 5, the remainder is 3. If you take 8 and divide by 5, the remainder is 3. So every number in here is either 0 mod 5, 1 mod 5, 2 mod 5, 3 mod 5, or 4 mod 5. Okay, so now to figure this out, we have some rules that we have to keep consistent. The first is that if we choose an element that is 1 mod 5, we cannot choose an element that's 4 mod 5. So, for example, if I chose 1, I cannot choose 4. Because if I did, 1 plus 4 would add up to 5, which is divisible by 5. And we don't want any pair to be divisible by 5. Let's choose another example. So if I chose 6, which is also the same as 1 mod 5, as I gave before, I cannot choose any number that's also equivalent to 4 mod 5, which would be something like 9, right? Because 4 mod 5 is the same as 9 mod 5. Why? Because 4 divided by 5, the remainder is 4. 9 divided by 5, the remainder is 4. So if I chose 1, I cannot choose any of the 4 mod 5s. So I cannot choose 4, I cannot choose 9. Why? Because 1 would add with those to give a number that's divisible by 5. Okay, so that's the first rule. The second rule is very similar. No element can be 2 mod 5 if there is an element that is 3 mod 5. And the same kind of principle or understanding applies here, because think about it. If you chose a number that's 2 mod 5, like 2, and then you chose 3, 2 plus 3 is 5, and that is not allowed. Any number like 3 mod 5, which is right here, I gave another one, 8 is also 3 mod 5, can't, because 2 plus 8 is 10. So these are the two rules. So just with these two rules alone, we can figure this out. So let's do that. First and foremost, let's only select numbers that are 4 mod 5. Okay? So we want all the 4 mod 5s and their equivalent. So obviously 4, 9, 14, 19, 24, and 29. Those are all equivalent to 4 mod 5. Because I chose those, I cannot choose any 1 mod 5s. So I have to cancel all of those out. So 1's out, 6, 11, 16, 21, and 26. Okay. Now let's look at the second rule. If we are going to use 3 mod 5s, we cannot have any 2 mod 5s. So I'll circle all the 3 mod 5s because I'm going to use those. 3, 8, 13, 18, 23, and 28. But I have to cancel all the 2 mod 5s. So 2, 7, 12, 17, 22, and 27. So far, I have abided by the rules of the question. So how many numbers do I have? I've circled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 so far. But 12 is not one of the answer choices. Okay. What's going on? Why is that? Well, because look at the only numbers that are remaining are multiples of 5. And if you added any 2 of them, they would also become a multiple of 5. They would be divisible by 5. So none of those are allowed. But you can use one of them. You can put in 1, but no more than 1. Because as soon as you put in a second one, you'd be able to make a pair, like 5 plus 10, which is 15, and that's divisible by 5. So you can only put 1 of those remaining 6 numbers. That's why you put that one final one to get 13. So for example, the 13 numbers I just circled is one such subset that would satisfy this equation. So number 17, the answer is 13, which is choice B. Triangle ABC has AB equal to 27, AC 26, and BC 25. Let I denote the intersection of the internal angle bisectors of triangle ABC. What is BI? So I've drawn a triangle and I've drawn a circle, and it will be clear hopefully as to why I drew the circle. So first let's label this. We've got A, B, and C, and they've given us the side lengths as 25, 26, and 27. Now let's draw in the angle bisectors. So each of these lines that I'm going to draw bisects the angle that it is going to emanate from. So the first angle bisector approximately something like this, and then the next one approximately something like that, and the next one approximately something like that. So that point where they all meet is I, and that is the point that they want you to figure out the distance from B. Now what's interesting is that this is known as an incenter, that I is the incenter of the circle. It's also the incenter of a triangle, of the triangle. So what I'm going to do at this point is draw radii for the circle that are tangent to the triangle. So this is a right angle, this is a right angle, and this is a right angle. So how do we proceed now? Well, the first step, of course, is to look at the fact that they've given us a really nice scenario to figure out the area. And we can figure out the area in two ways and then equate them. The first way is, of course, to use the triangles. And the first one is this one right here. And that's going to be 1/2 base, which is 27, times height. And the height is that, which is the radius. And of course, you add to that the area of that triangle, which is 1/2 base, 25, times the height, which also is the radius. And then add to that triangle right there. Now, the second way of figuring out the area is known as Heron's. And some of you, of course, have heard of this formula. Heron's formula basically says that the area is equal to S times S minus A minus S minus B times S minus C, where A, B, and C are the side lengths, and S is equivalent to half of the perimeter, so A plus B plus C divided by 2. So we can do that. In this case, if A plus B plus C is 25 plus 26 plus 27 divided by 2, that means S is going to be equal to 39. So using Heron's, this basically becomes 39 times 39 minus A, so that is 14, and then 39 minus B, so that is 13, and then 39 minus C is going to be 12. Yeah. So there we go. This should let us figure out R, and then once we have R, we can use Pythagoras to figure out BI. So first thing, of course, is let's add all this up, and when we add up this side, we get 39R. And this side, we're not allowed to use a calculator, but we can break this up into prime factors. 3 times 13 times 2 times 7 times 13 times 2 times 2 times 3. And this is 39R. So there's 2 13s, so that's going to come out. There's 2 3s, so that's going to come out. 2 2s, so that will come out. And the only thing that doesn't is the 7 and the 2, so that's just going to leave me with root 14. So there we go. R is equal to, and this 39 is the same as 13 times 3, so R is just equal to 2 root 14. All right, so can be done without a calculator. Now, we have R, so we have this distance right here. It's 2 root 14. Right here, and we want to figure out BI, but it would be very helpful if we can have this, and we can just break it up, right? We can call this Y and Z, Y being the distance from there to there, and Z being the distance from there to there. And then similarly, this is Y and X, because remember, this is going to be the same as that, because those are tangent points emanating from the same point. From C, if you draw a tangent to the circle, it will be equal to the length of the other tangent. So that's Y and that's X, and similarly this is X and this is Z. So very quickly, we know that X plus C is 26. We know that Y plus Z is 25. And X plus Z is 27. And if you add these all, you get 2X plus 2Y plus 2Z is equal to 78. And then X plus Y plus Z, therefore, is 39. And then X plus Y is 26, so we can just put 26 here. And then very quickly, we get Z equal to 13. And there we go. We have everything we need now to figure out BI. BI squared is equivalent to 2 root 14 all squared plus 13 squared, which is 169. So this looks like 4 times 14 plus 169, and that is 225. And therefore BI is equal to 15. So it works out really nicely. And therefore number 18, the answer is A. Adam, Benin, Chiang, Dishan, Esther, and Fiona have internet accounts. Some, but not all of them, are internet friends with each other, and none of them has an internet friend outside the group. Each of them has the same number of internet friends. In how many different ways can this happen? So we have to first make a list of number of friends, and then for each we will figure out the number of possible cases. The choices are either 1, 2, 3, and 4. There's 6 of them, and they can have some friends, so the number of friends is not 0, but they cannot have all, so the number cannot be 5. So we're only dealing with 1, 2, 3, and 4. And the good news in this question is that 3 and 4, these are complementary with 1 and 2. And what that means is that 1 behaves like 4 and 2 behaves like 3. And the reason they're complementary is because non-friendship plays the role of friendship. So if you have 1 friend, you have 3 that are not friends. But if you have, you have 1 friend, but you have 4 that are not friends. If you have 4 friends, then you have 1 that's not a friend. You see what I mean? It's complementary. That's why the numbers are the same. So we obviously have to figure out the numbers for 1 and 2. All right, well, 1 is the easiest one. If you have a choice of, let's say I choose Adam, let's say A for Adam, he can initially choose any of the 5 remaining friends. But then the next friend, let's say Chiang, 2 are gone, right? If Adam chose Benin, 2 are gone, so Chiang can only choose between the remaining 3. So there's 3 choices. So the number of combinations is 5 times 3, which is 15. So that is how many different combinations for 1 friend, and then that would be also the same for 4 friends, because those are the same. Now we have to figure out for 2, and when we do, we can write that number in here for 3. And then in the end, of course, we're going to add them all up. For 3, there's 2 different sort of scenarios. The first scenario is when you have 2 groups of 3. So, for example, A, B, C are friends. A is friends with 2. And then D, E, F are friends. D is friends with 2. And the way to do that is for A, from the 5 people, he will choose 2. So it's a choose notation. From 5, choose 2. And when you do that, it is 10. And then the other 3 are just together by default. Once that happens, D, E, and F are the only ones left, so they're all friends. So this is the first part. The second part is an additional way of doing it, and that is an interesting way in the sense that you put it into sort of a hexagon type pattern. And since there's 6 of them, 6 friends I should say, they go along the 6 vertices, A, B, C, D, E, F, like this. And again, you sort of group them. So let's say these are friends. A is friends with 2 people. Well, how do you do that? Similar as before, it's from 5, choose 2. But then the next 3, they have by default been isolated as friends, but there's different permutations. 3 factorial different permutations, which is 6. So this is 10, and this is 6, so you'd have to multiply 10 by 6 to get the total, and that's 60. So you have to add this 10 to this 60 to get the total, and that's 70 for a scenario where each person has 2 friends. And the scenario with each person has 3 friends, that's complementary to 2 friends, so that's also going to be 70. So the total number for this question is 15, 70, 70, and 15, which is 140 plus 30, which is 170. And therefore, number 23, the answer is B. Consider the polynomial p at x is equal to the multiplication of x to the 2 to the power of k plus 2k, and they've expanded it out. The coefficient of x to the power of 2012 is equal to 2 to the power of a. What is a? First, let's write out all the terms. And then now, I'll try my best to discuss how to come up with the coefficient of x to the 2012. So, every term in the expansion of the product is formed by taking one term from each factor and multiplying them all together. Therefore, we pick either a power of x or a power of 2 from each factor. For example, we would take this and multiply it by this, or we would take this and multiply it by this, and so on, right? You take a power of x or some power of 2, because these are all powers of 2, as you can see. So that takes care of that one. They're just explaining. Now, every number, including 2012, has a unique representation by the sum of the powers of 2. That representation can be formed by converting it to its binary form. For example, 2012 equals that, meaning 2012 is equal to 1024, so on. So if you're familiar with binary, it's very helpful, and I encourage you to learn what binary actually is. So for example, this term, 2012, in binary is written as 1, 1, 1, 1, 1, 0, 1, 1, 1, 0, 0. Now, what does that mean? It means that anytime there's a 0, you don't need to include it, whatever it is equal to. For example, this is equal to 2 to the power of 0. This is equal to 2 to the power of 1. You don't need to include it in the sum. But when there's a 1, you do need to include it. So this is 2 to the power of 2. This is 2 to the power of 3. This is 2 to the power of 4. This is 2 to the power of 5, and so on. 2 to the power of 6, 2 to the power of 7, 2 to the power of 8, 2 to the power of 9, and 2 to the power of 10. So, for example, in our number, wherever there's a 1, you include it. So you're going to include this guy, this, and this. You don't include 2 to the power of 5 because there's a 0, but you include that, and the last 2 you don't include because those are zeros. Now what you do is you add up these numbers now. 2 to the power of 10 is 1024, plus 2 to the power of 9, which is 512, plus 2 to the power of 8, which is 256, 2 to the power of 7, 128, 2 to the power of 6, 64. You don't add the 2 to the power of 5, but you do add 2 to the power of 4, which is 16. You add 2 to the power of 3, which is 8, and finally you add 2 to the power of 2, which is 4. Then you don't need to add 2 to the power of 1 or 2 to the power of 0 because those are zeros. And when you add all this up, you indeed get 2012. So that is what they mean by that. Now, the term x to the power of 2012 was made by multiplying x to the power of x to the power of 1024, which is right here, from that part of this equation, and then the 5x to the power of 2012, and so on, right? We have to combine them to eventually get 2012. And therefore, that is done by combining, as we shown here, x to the power of 2024, x to the power of 1024, x to the power of 512, x to the power of 256, x to the power of 128, x to the power of 64, not x to the power of 32, but yes to x to the power of 16, x to the power of 8, and x to the power of 4. So we did not include this guy, and this guy. And that's the only way. When you multiply all those, you add the exponents, and when you add the exponents, the full exponent will become 2012. Now, from these guys right here, this one, and this one, we didn't actually use the powers of x. So that means we had to have used the numbers. We have to use something, so we must have used these guys when we multiplied it out, when we were figuring out x to the power of 2012. So that's what they mean, that thus from x to the power of 32 plus 32, x to the power of 2 plus 2, and x plus 1, 32, 2, and 1 were chosen. And therefore, those make up the coefficient. So it's 1 times 2 times 32, and then all those powers of x, I'm not going to write them all out, but when you combine them all, you add the exponents, and that exponent becomes 2012. Therefore, that is the coefficient, and that is 64. And now they want you to express it as a power of 2, and that's not a problem. 64 is 2 to the power of 6. And therefore, A is equal to 6. So therefore, the answer to this question is 6. So number 20, the correct answer is B.